Hi everyone, so this is the second part of lesson 4 about domain and range. We just finished example number 3. We're moving to the example number 4, and I want to finish this so that we can all finish this and start doing homework. Alright, example number 4. Draw a graph of relation which has the domain. Now we understand this symbol. This means in the set of, okay, x in the set of all real numbers, and then y is less than or equal to 2. Okay, less than or equal to, which means including 2, but then less than. Alright, with only one x-intercept. So I can make a sketch here. Now the domain is all real numbers, so I need to make sure I cover all to the right, all to the left, left, right must be covered. Crossing x-intercept at once, okay. And then smaller than 2. So you can do the following. Just a minute. For example, you can draw something like this. You can say you have a function that always exists at 2, okay, because that's the largest number, right, all the way to the right, right? It's a straight line, okay? It's cover everything to the left is as 2, and then you want it to be including all the y lower than 2. So, and then you go down, just a straight line going down like this, okay? So this way, left and right is all covered, so it's all real number. And then this way, it only have one x-intercept, and then it will meet the range. Now let's try the second one. How about 2 x-intercept? Okay, so we have see similar example. 2 x-intercept. Now we can do a parabola. Okay, this is not the only answer. This is kind of an open-ended question. Okay, we can have a parabola like that. All right. So which intercept the highest point at 2? And then here you go. So this arrow means it go down forever, so meet the range requirement. And this is all arrow also mean going left and right forever. So it's also meet that requirement. So these are some example. There are more than one answer. Explain why it is not possible to draw a graph which has domain and no x-intercept. Does it have to be one x-intercept and two x-intercept? How about no x-intercept? The answer is it cannot, because the range explicitly say y is anything, could be anything less than or equal to 2, which including 1, which including 0. Okay, so this one say the range can have y equal to 0. And then we know whenever y equals 0, what is that? Whenever y is 0, we have x-intercept. Remember lesson 3? So since 0 is part of the range, we must have an x-intercept somewhere. Alright, here's our last example. A high school football team is hosting a banquet, celebrate the winning champion, and then the caterer charge a setup fee of $500 and then plus $20 per person. So this will be captured by this formula. So in the future, we will know how to write this formula, but for now, you can just use it, okay? So the cost is $500 plus $20 per person and represent the number of people. All right, make a table of values. So you can order data in many formats. Table of values is one of them. N is the independent variable. And then depending on how much people coming, C, the cost will change. So C is depending on N. With 8 entry for a minimum of 100 and maximum 500 people. Okay, so it says 100, okay, 200, 250, 300, 350, 400, 500. All right. So with just 100 people times 20, that's 2,000, 2,500. That's how much it costs. With 500 people times 20 will be 10,000, 10,500. Oops, 10,500. All right, so you can fill in all the numbers in between. Okay, it's a linear function. It grows in a linear manner. Plot the A-order pairs on the grid. Is it if all possible order pair were plotted on the grid, state the domain and range of the relation. Explain why there are restrictions on both. Okay, so using this diagram, so I will first say this is 0, 100, 200, 300, 400, 500. Okay, I don't want to move my, let's draw the line there. Okay. Oh, okay, let's use that as a 0 because with the window I don't want to move it any. Okay, so the bottom there is 0, and then on the top here, now I need to cover 10,000. Okay, 1, 2, 3, 4, 5, 6. So if I make this 12,000, all right, this will be 10,000, this will be 8,000, 6,000. So for every graph, you just need to work out the scale, right? And then you plot it. All right, like the scale doesn't work out very well because each box is 400 instead of 500. But anyway, so if you plot it, this will be the result. If all possible order pairs were plotted, state the domain and range. Now, how come we limit to 100 to 500? Because the caterer, they're not coming if it's less than 100 people, and then they can't host more than 500 people. So the domain, there's a restriction. The domain is X has to be in between 100 and 500. And now this graph is actually not very accurate. It should be like dots. Can't be totally connected. The reason is you cannot have half a people. So you write X is integer. All right? Because you can't charge half a person. Well, maybe some babies could be, but then you can't. And then for the dollar, same thing. Like if the domain is whole number, and then the range will also be whole number. But for now, I'll just write, okay, the ranges will be a little bit more tricky. Just say it's in between 25,000. That's like the minimum charges, and then the largest is this much. Just how much they can host. Okay, and okay, this one is a bit tricky because you only tick on every $20 because adding up which person you're adding $20. But for now, I'll just write integer. It's not totally correct, but I think in order to finish this lesson, we'll just end it like that. Okay, all right. If it's just a line, you can say it's all real number, or like it's integer if you need to take on the whole values. All right, that's it. So this lesson is about domain and range, which tell you what are the inputs, what are the outputs. That's it. That's very simple. But then there's a different notation, how to write them, how to specify a range of data. Sometimes the data is real numbers, sometimes the data is integer. So maybe that will start to make people confused what's going on. But in simple words, domain is just all the x's, all the input, and range is just all the possible y values. Okay, enjoy. Bye.